Okay, good afternoon, ladies and gentlemen. My name is Letha Tamimi. I'm SEMI Europe President. I would like to welcome you to today's third executive keynote session. Today's session is a continuation on the theme from yesterday on the IoT, the Internet of Things, and the next 50 years of Moore's Law. It gives me a great pleasure to introduce our third speaker, Rod O'Shea. He is EMEA Regional Director, IoT Group, Intel Dublin, Ireland. Rod is responsible for extending the research, will address all of the challenges and more in his key role. He is responsible for extending the reach, benefits, and value of Intel technology into new business areas. This includes solutions embracing Internet of Things, new infrastructure, smart manufacturing, consumer electronics, and energy. Rod has been with Intel for 20 years. He has held a variety of international positions within Intel, both sales and marketing groups and product divisions. Rod holds a first-class honors degree in operational research and computing. Without further ado, I would like to ask you to join me to please welcome Rod stage for his next keynote speech. Rod, please.
Thank you, Leith, and thanks, Luci, also for the great organisation of this event, which is wonderful. By the way, that was a better introduction. I did a speech in Dubai last week, and I came on stage and I was introduced as an Intel heavyweight. And if you look at my stomach, that wasn't the way I wanted to be introduced, so that was a far more professional introduction. We're going to talk about Internet of Things, and we're going to kind of link it to the next 50 years. I'm going to talk a bit about Moore's Law. I am going to talk about some of the key trends we see globally and how that then links to opportunities, I believe, for each and every one of you in the room. So Moore's Law was postulated 50 years ago, 1965. So Gordon Moore basically then made a prediction that you could roughly double the capability or half the size of silicon every couple of years. Now, looking around the audience, I don't think there's anybody that was born 50 years ago. So this was an amazing thing. And I'll just show you one quick video just to kind of talk about Moore's Law. If we could run the video, please.
50 years ago, it was just a prediction. It soon became a law, our law. Unlike other laws, ours was made possible by people. In the hands of a brash startup called Intel, a bold promise was made. A promise to create something powerful and amazing. A promise that technology could improve the lives of every person on the planet. A promise we would work tirelessly to meet. Year after year, we pushed limits. We broke records. We expanded horizons. And we had a little fun along the way. Inspired by Moore, we continue to be driven by his law.
Intel has been supporting me for over 25 years.
By changing the way people experience the world, we've changed the world itself.
The greatest accomplishments in life are not achieved by individuals, but they're achieved by people pulling together for a common goal.
For half a century, Moore's Law has propelled us forward. And as we celebrate its 50th anniversary, we recognize that it's our Intel employees, both past and present, who have brought this promise to life. So let's ask ourselves, how will we transform the world in the next 50 years?
So if we just reflect on that, we saw the 4004 in 1968, a couple of thousand transistors. Current core product has 10 billion transistors. And just to give you a feeling for the rate of change of that innovation, if we'd had the same rate of change in the car industry, every car would do about 400,000 miles per gallon, and it would be cheaper to throw away your Ferrari than park it. So that just gives you an indication of the type of immense turbine that's been created, and it's not stopping. I'm just going to give you one simple example. Intel's talking about our Curie module, which is basically a full compute technology in the size of a button. So you could have 10 or 12 attached to your jacket quite easily, and that could give you all kinds of information and things that you could sense. And I'm going to talk now about the implications of that compute technology and how that's going to affect everything. And I'm going to particularly talk about the Internet of Things and how we see this innovation in compute linking to the Internet of Things. So I'd like to start just with kind of the demographic of the Internet of Things. I've been lucky enough to work in the embedded industry for 30 years now. And the embedded industry has been all about how you take compute technology and put it in new and different devices, things that didn't previously have compute technology. And a great example is we started adding technology to automatic telling machines, and that provided a different value of service. So that was the basic embedded industry. And I would argue that started 40 years ago. I think we started hitting the peak of that as we go back 2 or 3 decades. Next, we started to connect it. And this started happening about 10 years ago. So the big motivation to start connecting these things was predictive maintenance. Can I go down and start to manage a device, and can I connect it? And that was really the driving force. At that time, there really wasn't the understanding around linking these capabilities to a data source and providing incremental value, but we started getting basic connection. Now we're moving to the world of smart, and that's the innovation that we're seeing now. And this is the idea of intelligence everywhere and things connecting and systems of systems. So rather than just having one device connecting to the cloud or the infrastructure, intelligence is put in everywhere, and things start to interact with each other in a very specific way. And this creates new opportunities for the deployment of solutions, technologies in many different areas. And I'll talk about some of these, and our view of this over the next 50 years as we go through the rest of the presentation. How big is the Internet of Things? The first question I always get in the boardroom is it big and is it real? And part of the challenge we have for the Internet of Things as an industry is there's so much hype going on. If you look at the Gartner hype curve, we're at the very peak of the hype curve for the Internet of Things. And there's a lot of innovation that's happening that will be great and will add value, and I'll talk about that. There's lots of innovation that's happening that is kind of innovation that's not going to lead somewhere. I was with an entrepreneur last week in Istanbul, and he's working on a whole series of technologies to walk pets. Quite kind of interesting. I don't think there's going to be a multi-billion opportunity for robots that walk pets. I think that's a very kind of niche area. And people sometimes think of the Internet of Things in these kind of niche kind of ways. There are some really meaningful deployments happening now, and there's more to come. But basically, the Internet of Things is big. Pick your favorite number. 50 billion in 2020 actually was first postulated by Ericsson, going back almost a decade. IDC is talking about 200 billion connected things. And if you think about it, if you think about the number of connected things on the planet today, and you do the math and you look at phones, PCs, laptops, infrastructure, intelligent things developing, there's about 15 billion connected devices. So if you just think about that, 85% of the things we would want connected are not currently connected. And there's a big infrastructure out there that we need to integrate into. And that infrastructure, when it was deployed and when it was created, the idea of connecting it wasn't there. So if you just think about that, that's a massive opportunity. But a challenge, integrating with infrastructure is a massive challenge. My favorite IoT joke is that God created the world in 7 days. And the reason it only took God 7 days to create the world is there was no legacy infrastructure. And I think that's a good wake-up call for us all as we start looking at deploying new solutions, but also how we link into the existing infrastructure of technologies. So it's a really, really big opportunity. And by the way, by 2020, these things will be generating about 50 zettabytes of data. Now, I won't embarrass this very technical audience by asking you what a zettabyte is, but when I had an internal discussion with some of our key architects in Intel, about 50% knew exactly what a zettabyte is, which, by the way, is 1,000 exabytes. And nobody could tell me, or actually a few people could tell me what 1,000 zettabytes were. What's 1,000 zettabytes? Does anybody know? It's a yottabyte. And we'll all be talking about yottabytes in about 10 years, so we should start getting those kind of data points in our minds now. So the key thing with the Internet of Things is there's things, and they're going to connect. So Intel's kind of view is that as you connect these things, they need to connect in a very secure and managed way. But what's profound with the Internet of Things is these things will generate data. That data can be analyzed in some kind of way to create valuable information that can be used to drive value to a citizen, a business, a government. So it's all about the thing connecting to the cloud and generating data. And by the way, the cloud is not necessarily a centralized thing. People get confused between cloud and data center. The cloud can deploy across that demographic, and we introduce this idea of edge cloud with gateways. So I won't have time to go through the whole kind of taxonomy of the Internet of Things here. Broadly, we think there's 3 types of Internet of Things architectures. There's a mobile architecture. Think of all your handhelds that move around. These will connect through a network into data center cloud. Then there'll be a whole host of industrial capabilities. I don't need to talk to this audience about Industrial 4.0. All of the innovations in that environment. And typically, those things and devices will connect in via a gateway. And we see the gateway as quite profound here to enable you to manage that infrastructure of things. And just to give you an understanding of some of the complexity of managing these things into gateways, I was with a company in the Middle East a few weeks ago, and they're helping to deploy Smart City Dubai. Their gateway currently is managing over 350 different protocols. Just to give you an indication of the complexity of some of the things that you'd want to manage. Obviously, a gateway in a car would need to support CAN bus. A gateway in a vending machine would need to support VM bus. So you get the idea. But the gateway can start to add intelligence into these areas. And similarly for the home, I think everyone's seen the emerging interest in the home for all kinds of solutions around energy, around entertainment, around security, integrating your home experience into your experience outside the home. These are typically managed through some kind of home gateway. So we see the gateway as quite a profound part of the architecture, and making sure that gateway is architected correctly to have intelligence at the edge to enable you to manage your things effectively, but also to provide a key security portal and gateway into that environment. So if you think about it, when a plane's in the air, so if we fly from Munich to New York on a new 380, that plane, when you look at all the control systems, generates about 0.5 terabyte of data in total on that flight. Now, actually, you don't want to send all that data back immediately into a centralized cloud. You want some intelligence at the edge saying, okay, I'm monitoring the airflow, I'm monitoring the air pressure, I'm monitoring the engine functionality and capability. Now, if something's changed outside a range, I want to pass that information back into the cloud. So this is the rough view of demographic, and Intel has introduced, first of all, the concept that all things have to be connected, secure, and managed. If they have power, they have the ability to compute. And also, we introduce this idea of an application-ready platform, things that can start to connect into this environment. And this whole idea that we don't solve these Internet of Things architectures in isolation, we need to start building up standard architectures to deliver the volume capability to deliver these solutions. And part of the challenge for the Internet of Things is that there's lots of really good innovations at the moment, but there's silos of innovation. And I won't go through the whole kind of standards walk today. We can certainly talk about that offline. But there are a couple of quite significant initiatives that Intel sees as profound. The Industrial Internet Consortium, it's almost 200 members now, massive support here in Germany, looking at how we practically deploy industrial internet solutions, and also the Open Internet Consortium, talking about how we provision and deploy solutions onto the network. No one vendor, no one company is going to deploy the Internet of Things. It's going to be done via the community, and these partnerships are critical. And as I close the kind of first half of the presentation, I did want to make a couple of comments about a few specific things Intel are doing. One of the things we've done recently is we've launched a program called the Ignition Labs. So what's interesting is, for me being Internet of Things General Manager for Intel here in EMEA, I see lots of innovative ideas for the deployment of the Internet of Things. Actually, we counted last month, we had over 100 business cases or solutions that were proposed to Intel in some shape or form. Now, what's interesting is of those ideas, less than 10% are really deployable, and actually probably about 10% again have a valid business model for deployment. So all of these kind of ideas that are coming up, we need to hone down into deliverable solutions. And the idea behind these Intel Ignition Labs is we have capabilities that include our technologies, our architects, we have business model experts working with our partners, but more profoundly working with our customers in an innovation community to deliver a solution. I talked to the board of a conglomerate in Turkey last week, big conglomerate, $10 billion holding. Their CEO basically said, Rod, he said, we're going to hold on the Internet of Things for the next year because we're just too confused. There's too many different people coming to us with too many different solutions. We're going to wait. So we agreed that we would integrate a lab process where we drive this innovation and technology in a very structured way. So call to action for you if you're interested in that. There's 8 labs around EMEA at the moment that have been formed in the last year. One here in Germany, in Munich, but do hook up. You've got the email address and the handle there that you can connect and start to innovate with our labs process. And there's lots of early wins. So when people say to me, is the Internet of Things real? I talk about deployments that have happened. And we have many, many Internet of Things deployments in many ways. If I just pick one, when I talk about the way we think about opportunity for adding IP and intelligence to things, my favorite recent one, I live in the UK. I spend most of my life in Heathrow Airport for various reasons. So we work with Heathrow Terminal 2 on an innovation process around restroom toilet management. And basically the problem they were trying to solve was, how do we efficiently and effectively keep everything clean, but we don't want to have a massive investment cost in doing that. So the simple idea was taking a thing, which was a door, we added a simple people counter capability to the door, and we changed the business process such that the restrooms at Heathrow Terminal 2 aren't cleaned every hour, they're cleaned every number of people. The initial model was 200. So really, really simple thing. So we added intelligence to that thing, which was a door. We added a simple connection to that and a cloud service behind it. And now the scheduling of the maintenance is done via numbers of people rather than an arbitrary slice, which in this case was time. So that's the spirit of the Internet of Things, real deployments with real business model benefits. So just a couple of closing things on business before I want to talk about the next 50 years and some of the challenges. when we're lucky enough at Intel, and there's probably many companies here that have similar discussions, when we sit in the boardrooms around Europe, Middle East, and Africa, we sit with the CEOs and the C-suites. What the conversation typically comes to, we don't really understand the Internet of Things, we don't know what it is. So we have some very basic discussions. Where in the business are you really generating valuable data? Do you know where that is? Do you know what you're doing with that? How are you doing that to drive competitive advantage? And you start looking, for example, at all those touch points with customers and all the opportunities to generate useful data. You can start having those discussions. So everyone should be asking, how does this change really affect my business? I had a great example last week with a company that made air compressors. And they said, Rod, we get it now. We don't make air compressors, we deliver air. So we're delivering value and we're delivering a service. So you start to see these transformations happening with business. And I'll give you a couple more examples when we talk about some of the trends. How does Internet of Things make these new collaborations possible? Simplistically, we have the enterprise IT world merging with the OT operating technologies world. And they're very, very different. And the way that those capabilities come together are very, very different. I'll give you a simple example. Actually, here in Germany, I had a meeting with the leadership team of a retailer, and they wanted to talk about the store of the future. So the first question I said was, well, how are you managing the data? How are you managing the brand and the consumer experience? They said, well, we don't work with data. That's the enterprise folks in our business. We just design the store. So we want to talk about how it looks and feels. We don't think about the way data flows. That's somebody else's business. So you have a massive disconnect between IT and OT in many of these companies, and bringing them together becomes key. And I have a lot of fun in board meetings kind of introducing the head of enterprise and the head of OT, who perhaps have worked on the same board for many years but haven't taken the time to have a conversation about data. So lots of changes that are happening out there. So that's the kind of practical business-oriented IoT. The challenge for this speech was to talk a bit about some of the major trends we see emerging. And I wanted to just think about some kind of higher ambitions for what we do as the technology community. And there's 4 big ideas. And I'm sorry the font's not perfect there for those at the back of the room, but caring for an aging population, carbon footprints, urbanizations, and feeding the planet. And when people say to me, is Internet of Things real? I say yes, and I talk about deployments. And when they ask, is it profound? We have some massive global challenges as a community that we have to fix. These are kind of becoming more and more understood with communication, with the advent of more and more social media connectivity. But we have to solve them, and technology will be absolutely profound to all of these. So let me just talk about a few of these. So caring for an aging population. So I don't know if you can see all the data points at the back of the room. You always know, by the way, it's quite an interesting foil when people start taking pictures. That's always a good sign. So if it's a really good foil, everyone takes a picture. So that's the challenge. So the chart shows population in millions on the planet. The blue bar is the age of people 0 to 14. The green bar is 60 plus. So look at 2013, about 2 billion people under 14, 841 million that are over 60. By about 2025, and those of you that if there's anyone in the room that's a teenager, 10 years away sounds a very long time. For those of us that are over 35, we realise how quickly 10 years goes. So in a relatively short period of time, we have an equal population between youth and aging and over 60s. But then go to 2050, 3 billion people on the planet will be over 60. And this is going to be about of a population of 10 billion and about 2 billion under 14. So if you just look at that data and think about, okay, well, what's the problem statement for us first of all, as a planet, but also as a technology community, is we have a lot of older people we need to care for. And by the way, many of us in this room will be using and consumers of these solutions. So we better get cracking now to make sure that they're built. And just a couple of kind of data points. By 2015, 40% of people will be over 60. Now, in the US, 10,000 baby boomers every day are becoming 65. 8 million will be over 80 by 2020. So you just start to see the volume requirement here. So then you start thinking of, well, how do we solve this? Obviously, how do we give great care? And you always come back to certain strategies. So one, I think, key strategy is the home as a connected care centre. And I come back to the basic ideas and capabilities that we can start to deliver. A really kind of simple solution that we've worked on recently is the connected medicine cabinet. So, if you have somebody that's at home and they're alone, or there's aged people together, are they taking their medicine? Is the medicine cabinet being opened? Are the medicine bottles being opened? You think from a technology point of view how easy that is to solve. There's probably not anyone in the room here that it couldn't either sort out that themselves in a couple of hours on a workbench, or find your favourite maker and get it done at the weekend. Really simple thing. But again, you put that into a solution that's part of the connected home and start to look at how you build up those kind of capabilities. And again and again and again, we're seeing that hospitals are overrun because they're not able to take patients and put them in the home because they're not sure that in the home they're going to be, for example, taking the right medicines. So this is a great example, I think, of the practical implications of the Internet of Things. So next, carbon footprint. The world will be 7.2% warmer by the end of the century. US will be responsible for a huge amount of the emissions. Energy usage, 2/3 of that is CO2 emission. I think generally there's an understanding now that there are environmental pressures and challenges ahead of us. And again, you come back to Intel. I mean, Intel is a massive manufacturing company. We manufacture huge amounts of silicon. And we've started implementing smart factories, looking at how we can efficiently drive those factories. We have individual machinery in our fabrication facilities that have more technology than an oil rig. That there is really kind of massive capability. But just some simple things by introducing intelligence into that process. Started with the basics like predictive maintenance, but then vibration sensing, looking at the analytics of how that vibration may lead to potential failure and the potential need for recalibration. And you can start to really build up far more effective use of capabilities. So technology plays a profound part in that area. Managing the urban boom. Who in the room's heard of Shenzhen in China? So about 1/3 of the people in the room. It's bigger than Sweden. So this is just kind of a data point. 440 cities in emerging markets will produce half of the global GDP growth. 46 of the top 200 cities will be in China. Half of the urban dwellers will live in Asia. So again, go back to our 2050 model. Population of the planet today, about 7.5 billion, maybe slightly higher. Population of the planet by 2050, it can't be precise, but let's keep the math simple and we'll say it's 10 billion inhabitants on the planet by 2050. So what's interesting today is of the 7.5 billion people living on the planet, about half live in urban environments. By the time we get to 2050, all of the growth, the next 2.5 billion people coming onto the planet, will live in urban environments. So we're seeing this massive move of people, of urbanization, and we're seeing the huge challenges that causes. And we see ebbs and flows, and obviously in Europe at the moment we have some very specific kind of demographic challenges as people are moving between countries, and we're starting to see challenges of relocation due to refugees and other things. But there's a massive, massive trend towards urbanization that's affecting us all. And figuring out how we solve that is a key challenge for technology. My own city is London. London's adding 2,000 people a week at the moment, 100,000 people a year, 1 million every decade. So if you just think about 2,000 people a week coming into a city that need housing, that need feeding, that need energy, that need water, and then that need education, that want to be entertained, that want to have a life. These are huge challenges, and technology is underpinning that. And we've been working with a bunch of education establishments in London for many years now, and we're working on a number of initiatives to look at how smart cities can run more effectively. And I've just given you a few examples there. But there are some significant challenges that we will need to overcome together. A simple data point for London is that water is a massive challenge for the globe, and by 2050, about half the population of the planet will not have access to the amount of water that they desire. So, and again, you think about this as a huge issue in many places, but an emerging issue in some of the communities like California at the moment, where there's a huge kind of lack in water capability. In London, a third of water that could be consumed is lost before it gets to point of consumption. So before it gets to the house or the business, we lose about a third of water because we've got pipes that are 100 years old, there's 30,000 kilometers of those. And then you think about, well, how do I solve that? I can start to add intelligence to those pipes. I can start to get flow management. I can start engaging the community in education. I can start engaging the community in reporting where there's leakage and so on and so forth. So these are macro issues, but technology underpins those. And this will be a fundamental part of the way that we move forward. So urbanization is a key area. And then the fourth thing is feeding the planet. So actually there's 17% more food being generated than 30 years ago. Frightening data point number one, we're wasting about a third of all human food produced. And given that there are people on the planet that's starving, this is something that needs to be solved, and technology can really underpin that. But just to think about the needs of feeding the planet, if you look at the production of food needed to feed 10 billion people by 2050, we're going to need to produce about 40% more food. And that 40% more food equates to about 10,000 years of food generation from the start of man. So, we have to do things in 30 years that previously would have taken us 10 centuries. So these are big challenges. We're seeing all kinds of innovation in the agricultural space, growing more with less. My favourite company, my name is Rod O'Shea. I'm actually not Irish. We had this conversation earlier. I'm actually born in England. I do have an Irish surname. We're working with an agricultural company in Ireland. The agricultural company is called KEYNOTE, and they basically made feeding agricultural equipment for animals. I know everyone's talking about the connected cow at the moment, if you Google that. But basically, they provided this capability to feed. They figured out that they could start to look at how food was eaten by the animals and how then that would provide what they ate and the relationship, for example, to milk production in cows. So instead of just building a thing, which is something that feeds animals, you start to have an intelligent thing that generates data around the value and the delivery of your thing in terms of the supply chain. And actually now KEYNOTE is running basically an analytics business based on their technology. So we're seeing this profound change, and so that's a great example of making the supply chain more efficiently. We're working on a whole series of really, really cool projects at the moment. My favourite one at the moment is in Malaysia on rice field production, and basically it's looking at the relationship between that environment, the humidity of the soil, and rice production, and some very basic methodologies for tuning the irrigation of rice fields can increase the production. And you can start to mash that with the environment and the weather and the future capabilities of that, or the future state of that environment to maximize rice production. And again, these are really, really simple technology things. And again, us as makers, we can these sensor mechanisms are really simple. But putting them into a system and figuring out the analytics and the data around that and using that then to provide information that changes that system is the profound thing. And we're back to that intelligence everywhere example we talked about. So 4 major trends for the industry, for the globe, great opportunities for us in the industry. So we talked about Moore's Law, the implications to business. We talked about the demographic of the Internet of Things. We talked about 4 big ideas, And I think these big ideas are things that create opportunity and activity and engagement for all of us in the planet. And these are huge things that have to be fixed. So just in closing, wonderful journey with Moore's Law over the last 50 years. The next 50 years are going to be absolutely the center of innovation. We have the capability to do more and more. Great opportunity for everyone here, and a great chance for us all to contribute to the future of the planet. So with that, I'll close. Thank you very much for your time and attention. I have business cards here if anybody wants them. Thank you very much.
Thank you very much. Thank you very much, Mark. We have time for one or two questions. So we have time for one or two questions. Okay, while you think about it, I have a question for Rod. Rod, thank you very much for the global perspective on the IoT opportunities over the next 50 years. The question I would like to ask you is, how do you see, you mentioned opportunities, you mentioned challenges. How do you see the European semiconductor industry remain relevant in providing the right solutions in addressing these IoT challenges?
Yeah, so it's a great question. So I'm lucky enough to work. So in the countries I work in is Europe, Middle East, and Africa, and I see all the kind of innovations. So I think there's great opportunities, and I don't think any of these solutions are going to be solved kind of globally once. I do think there's an opportunity in all of these industries for huge innovation. My only counsel is we have to work together and collaborate with the right standards and the right capabilities. And by the way, events like this are just fantastic in creating those kind of linkages. I think there are industries where Europe absolutely leads. I think the industrial industry, smart energy, automotive, lots of media industries, retail are all areas where I think Europe has a profound part to play. And I think the key thing here is that these solutions will be built as a community and deployed globally. So there's huge opportunities, and I'm delighted that the ignition labs that I talked about earlier, we're already exporting huge volumes of solutions built in Europe to, for example, Asia, Japan, all over the globe, because everyone is looking for those points of innovation, and we can work together to deliver those solutions.
Thank you very much. I think there's a question from the gentleman there, please.
Do I need to switch it on now? Great. So if we look at the share of revenue that IoT gives to Intel right now, I understand it's about 4% of your revenues. Where do you see that in, say, 2025?
Well, I think the Internet of Things provides opportunity across all parts of Intel's businesses. So if you look at the demographic that I showed earlier, I think there's things. Those things are going to need to be built with some kind of silicon. They'll have some kind of capability above that. They will then connect into gateways. So that's a huge opportunity for the industry. Clearly, Intel is a significant player in that space. Then that has to go through the network, and we're seeing huge changes in the network. I think the communications industry very quickly, figured out network function virtualization, software-defined networking, and those kind of capabilities. And then there's clearly significant opportunities in the deployment of those solutions in the cloud. So, I think there's ways that we specifically account our business through business groups. But if you look at the opportunity from the Internet of Things, it goes across all of those areas. And I think in 10 years, we will talk about the Internet again, and because things will become a profound part of the Internet. And I think it really is the critical driver. And some of those big challenges we talked about for the planet, this is a long way away from the thing. The thing has to work in a systems of systems. I think it's a great opportunity for Intel. I think it's a great opportunity for everyone that works in technology.
Great, thank you. Thank you, Rod. Any further questions? Please. Can the microphone, please? A microphone. Thank you.
Thanks for your insight. I was just wondering, let's say the classical interpretation of the laws, Moore's law, in terms of shrinking the die, is that coming to an end?
So we believe that Moore's law is alive and well. I think there's going to be continued innovation, continued challenges. It's interesting. I've been working with Intel for 20 years, and every year there's been conversations around is Moore's law at an end. I think we're just going to see continue to see these innovations and focus around the continued delivery of more for less, lower power, and so Moore's law is alive and well. And actually, I was lucky enough to have a conversation with Gordon on this a while back, and Gordon said, Moore's law is alive and well. I know he's kind of a rude 80-year-old plus now, and he said, so for my lifetime, this is something that's going to continue, and then after that, it's somebody else's problem. So yes, Moore's law is alive and well. Thank you very much.
Thank you. Thanks again, Rod. Any further questions? If not, please join me thanking Rod once again, and thank you very much.
Thanks ever so much.
Do you have to join for lunch?
No, we can grab some lunch.